To perform the commissioning with the keypad, we need to plug it on the drive. The RJ45 port is under this small cover, so we can remove it and plug our keypad. If you want to keep the keypad in your hands, you just need the optional remote connection kit made by an adapter and the standard Ethernet keyboard. You plug it on the keypad and then into the drive. Using the keypad, we always recommend to have with you a USB key that can be plugged simply into the drive in order to store inside languages, software application, motor database, or parameter files in order to configure your drive as you want. And now we are ready to power on our system and start the commissioning. At each power on, the drive shows firmware version and application software version. By default, the drive has the EFC application software for multi-speed control, which is the setup for today. After that, being the first power on of the drive, after the unboxing, the display will automatically figure out drive setup wizard for the main configuration of the drive. User level is intermediate, which is the minimum user level for setup and startup of the drive. Drive setup is a step-by-step procedure useful to prepare the drive for the commissioning. The first step is the selection of the language. The default language is English, and it is possible to select a second language that is Italian, already stored into the drive memory. If you want to select other languages, the display asks to insert a USB key with language folder on it. Since the tutorial is in English, let's leave English as by default. Next step is the selection of the software application of the drive. The default is EFC for multi-speed control. Other choices are EPC for position control, DCP for serial communication, CAN 417 for DS417 communication. Our setup is with multi-speed, so let's leave EFC selection. Next step is load parameters from USB. This means that if we already have a parameter file and we want to download it into the drive, we can put it into the USB to configure the drive. In this case, we have a file.dat in our USB that we can select to download it into the drive. Since we are making the commissioning from zero, let's jump this step. Next step is the encoder mode selection. The default is none, which means open loop control without encoder. In our test bench, we have a gearless motor with Heidenhain ERN1387 SignCos encoder. So let's select SignCos encoder. Last step is the selection of the motor from motor database. Motor database can be recovered on the Download Center of WEC website and kept into the USB folder. This database includes a list of the most common motors on the market, as you can see. When you select the specific model, nameplate data will be automatically stored into the drive, simplifying the commissioning. The list can be extended based on customer needs, filling a simple form provided by WEG after-sale service. Our test bench motor is not into the database, so let's jump this step. At the end of the drive setup wizard, we enter into the standard menu of the drive. To continue the commissioning with the keypad, let's start the startup wizard, which is the first selection of the menu. Startup Wizard is a guided step-by-step procedure designed for the quick setup of the drive, assisting in the configuration of the main parameters. It includes a series of questions related to the various steps for entering and calculating the necessary parameters to ensure proper operation of the drive and lift application. The first step is the selection of the control type. The default is Asyn SSC, which means sensorless scalar control for asynchronous motors. In other words, it is an advanced VF control. Since we have a gearless synchronous motor, we must select SynFOC, that means synchronous field-oriented control in closed loop. Each setting is configured with its own default values to streamline the drive configuration process. To ensure all the parameters are automatically adjusted to the new settings, the drive requires load default command. This pop-up notification is designed to inform the user of the action being taken. Next step is the selection of the communication mode. The choice is between parallel I/O and can open. In our test bench, we have a parallel I/O configuration, so let's select this option. Next action is to set encoder parameters. For this, let's take a look on the nameplate of the encoder, where we find all the data necessary. Encoder voltage supply is 5.2 volts. We find it as a default value because it is a very common encoder. Encoder mode is already set since we did it into the previous wizard. Encoder pulses is 2048. The default is already correct. After the encoder settings, we proceed with motor settings. For this reason, since we haven't selected any motor from the database, it is necessary to take a look to the motor nameplate and fill all the data requested. Factory settings depends on the size of the drive we are using. Starting from the rated voltage, let's set 380 volts. Rated current is 22.4 amps. Rated speed is 255 RPM. Pole pairs are 11. It is possible to recover this calculation from a simple formula as it is not displayed into the nameplate. Torque constant is 13.79. This comes from a simple calculation, which is the ratio between the torque generated by the motor and the rated current required to supply it. After motor data, the wizard asks for mechanical data. Mechanical data are already set by default based on the size and version of the drive. Anyway, if we have a specific information about the plant, they will be useful in order to better calculate the inertia of the system and improve control, performance, and comfort. We aren't on a real plant, so we will take the default parameters, but let's scroll all the data listed. First setting is the selection of the unit of measure for speed references, which can be cabin speed in meter per second, motor shaft speed in RPM, or output frequency in hertz. We leave meter per second, which is the most simple unit of measure. Second selection is a selection of auto recalculation mode for the first 3 multi-speeds, every time the car speed is changed by changing the mechanical data of the system. If the parameter is set to manual, the first 3 multi-speeds will be entered manually. If the parameter is set to auto, the first 3 speeds are recalculated with respectively 10%, 100%, and 45% of the new car speed. Let's leave the configuration to manual. After that, we have cabin speed, that is the maximum operating speed of the system, which is set to 0.72 meters per second. Gearbox ratio is the reduction ratio between motor and pulley. Being gearless, it is 1. Rope ratio is the reduction ratio due to the rope rotation in the shaft between the various pulleys. Pulley diameter, car weight, the weight of the counterweight, load weight, and finally rope weight. Next step is the setting of multi-speeds values. Let's set multi-speed 0 low speed at 0.07 meter per second, multi-speed 1 high speed at 0.72 meter per second, and multi-speed 2 inspection speed as 0.32. It is possible to set up to 8 multi-speeds. After that, if we are using the EBC, it is possible to commission the EBC directly from the drive, since there is a CAN communication between them. In our setup, we have ADL500, so let's activate the EBC function setting EBC enable on. The other parameters to set for the commissioning of the EBC are few and can be recovered from the nameplate of the brakes on the motor. Brake holding voltage, in our case, is 104. Brake holding power, on the nameplate we find 77. Brake power mode allow to select the brake startup and holding modes. There are 3 different settings: full voltage, boost half voltage, and boost holding voltage. After that, the last parameters are brake power boost to define the time for which the output voltage is held equal to the value of the rectified input voltage, and then the CAN termination resistor, on or off, if there is or not a CAN termination. At this stage, we are ready to carry out the auto-tune of the motor, which means the real measurement of motor parameters and the automatic phasing of the absolute encoder. The display asks to enable the drive, so let's do it from our control box. After the auto-tune, automatically start the auto phase. At the end of the procedure, the display asks to open the enable and then recommend to save parameters in order to maintain all the settings and calculations done after power off. Typically, at the end of the startup wizard, when we are on a real elevator, we perform some trips up and down with different loads in order to understand if the comfort, the arrival to the floor, the performances and the safety are in line with the expectation. In this case, we have a test bench, so we don't have any load, and we will just simulate a lift sequence. Lift sequence starts with run command, which is start forward, as well as high speed command. Then we close the safety chain, and the motor starts moving at high speed with the same settings we have done during the startup wizard. Let's imagine that we are on a real elevator, so the cabin is moving now and reaching the floor. So when the cabin reaches the floor, the command changes from high speed to low speed. And then when the cabin is arrived, we remove run command and the brakes close. We have reached the end of this tutorial about the commissioning of ADL550 variable frequency drive for elevator application. We have gone through all the most important steps related to the wiring and to the parameter configuration for a multi-speed setting. Of course, all the information, the complete informations are available on the manuals of the product that are on WEG website. We hope that you found interesting and useful this tutorial, so let's keep in touch to the next one.